Okay, in this video what I'm going to show you is how to run descriptive statistics using the package JMV for Jamovi. And first what I'm going to do is I'm going to set up and I'm going to do this in a different script. I could do it in the same script as the setup, but generally when I use R for statistical analysis I like to modulate or create separate scripts with each script for a specific purpose. So I'd have one script for setting up, loading in my packages and my data frames, another running for descriptives, one for running power analysis, one for running, let's say, a correlation, and then a separate script for running the one-way ANOVA. And the reason for that is when I need to change the specific code, rerun a specific part of my analysis, it's easier to find. And a second thing I like to do then is at the end put them all into one master script. So I'd have separate scripts and then one master script I can send to other people if they want to see the analysis from start to finish. So I'm just going to create an R script up here, and I'm going to call it 02 descriptives. And the reason why I'm labeling them 01 and 02 is just to keep track of an order in which I created these scripts. And what I first need to do before I run any descriptive statistics is that I want to link this script to the setup script, so that if I say I'm using the psycho DF or wellbeing DF, R knows where those data frames are coming from, where they're being loaded in, and also what packages that we're using. So to do that, I'm going to create a section label called link to set up script, and we can use a function called source. And what source does is that whatever R file I put in here, it will run it if I run this command. So it would run this script from start to finish. So I'm going to type in, all I have to do is just in quotation marks type in the script I want to put in. Also it's necessary to indicate what extension the file is. In this case it's an R script. And then I can press run. And what happens is that my psycho DF and wellbeing DF are loaded into my environment now. So if I was just starting this up again from a clean environment, a new R session, I don't have to rerun this entire script, go here and click all this and run it. I could just click source 01 setup R if I just wanted to do my descriptive statistics. Okay, so first thing we're going to do is we're going to look at a bit more at our data frames. So, and I'm going to look particularly at the wellbeing data frame rather than the psycho data frame. Everything I can use here, if you want to practice it, I encourage you to do it on the psycho data frame. So let's view our data frame. And first thing I would like to do is just view the first few rows of the data frame, wellbeing.df. So we can see we have, what's that, 8 columns, and looking at this straight away, there's a few things that I'd want to change. In that I would want consistent naming styles. So for example, conditions in capital, everything else is in lowercase, so I might want to change that. And in this case they've been abbreviated, some of the names, so DEPR is depression, WellBe is wellbeing, and this is kind of stylistic thing, but I prefer to have the full name. And also there's another reason for that when we run descriptive statistics, so I'll show you in a second. So I want to change that. Okay, so another thing is I'm going to look at the structure, and all this does, it will print out each column and tell me the data type of that column. Is it a character, is it numeric, is it an integer, is it a factor? And just in case, what I want is that gender and condition are factors. And that will come into more in the case when we do an ANOVA and t-test. So into structure, we can see that in this case everything is an integer bar gender and condition. They're both characters. So later on I'm going to change them into a factor. Okay, so just what we just do is do a bit of data cleaning. So I'm going to rename these columns into a consistent naming style. So I'm going to take wellbeing df, and I'm just going to change the information inside it, and I'm going to do that using rename function. And remember, the syntax for this is rename your data frame new name equal to old name. So I'm going to put in wellbeing df, and let's say I'm going to put ID. I'm going to create a capital ID, capital gender, condition is fine, capital age equal to current column age, that's lowercase, capital pain, lowercase, capital fatigue, lowercase. And for depression and well-being, what I'll be thinking more here is just capitalize them, but also expand, give the full name of the construct. So depression, or I'm just going to move this down, well-being equal to well-being. I'll show you in a minute why I did that. Okay, so that's that part. I'm also going to change the gender and conditions to factors. So to do that, what I have to just do is type in the data frame I want. We use the dollar notation that will select the column. So I'm going to change gender, and I'm just going to say this selects the gender column that we've just created up here. Sorry there, what did I do wrong? Oh, I already ran that. So actually, before we look at anything, I'm just going to check that this worked, and it did. So now I'm going to change gender into a factor. So I'm just going to say as factor, copy and paste this information, put it in here. I'm going to do the same for condition. And this is just because if we're running certain statistical tests, like an ANOVA, we need, if we're putting in our independent variable or expects it, depending on the package you use, to be a factor. df times condition. And now if I check the structure again, and I can just rerun this code up here, you can see that now gender is a factor with 2 levels, female and male, and condition is a factor with 3 levels, high caffeine, low caffeine, no caffeine. Okay, so that's our kind of data cleaning done. Now we can go on to the descriptive statistics. So run descriptive statistics. Again, I'm just creating these comments, these labels, because it just makes our script easier and nicer to read and structures it a bit. So again, if we come back to it in a few months' time, it's easier to read, understand what we're doing, and it's easier for other people to navigate if we're sharing our scripts. Okay, so we're using the JMV library, and within that there is a function called descriptives. And the basic syntax of this function is that we specify the data set or data frame we're using. Let's say our data frame, and then we specify the variables we want to run descriptive statistics on. So variable 1, variable 2, variable 3. That's the very basic syntax of this function. We'll do this first, and then I'll show you there's ways we can make it a bit more sophisticated and get more information, but that's just the basic syntax. So what I'm going to do with our well-being data frame is I'm going to get the descriptive statistics for well-being. So to do that, just type in descriptives data equal to well-being df. So I'm saying take the well-being data frame, and then vars in terms of what we want. I'm not putting in multiple, I'm just putting in one, so I don't have to use the C. I'm just going to say well-being. Just to note with this function, when you're specifying the variables, we have to put it into quotation marks. I run this, what it gives me is a descriptives table with the number of participants for this variable, whether there's any missing data points, the mean of well-being, median, standard deviation, minimum, maximum, kind of standard descriptive statistics. Okay, so how can we make this a bit more sophisticated? Well, if I type in question mark and type in the name of the function, descriptives, what I'll get on the right hand side of my screen, and you'll get this with any function, is information on the function. So there'll be, and in every help section you'll get a description of what it does. You'll get a usage which will give you the name of the function and the arguments or inputs you can put into the function, and it'll give you what currently are the defaults. And then the arguments down here, you'll get a list where it describes each argument or each input you can put in and what it does. And then at the end, you'll get examples of how it's used, right? This help section is actually particularly useful. We haven't done it so much in the course, or showed it so much in the course, because a lot of help sections for packages are garbage in the sense that they're very technically written and they're not very helpful or beginner friendly. My advice would generally be to Google information instead, but you can check the help section first. But sometimes even I get confused by help sections because they're very technically written. Okay, so we can see if we look in the arguments, there is a lot of information there. We can split by, so we can say, can we split the variables by a certain categorical variable? So we can do that first. I'm going to do that. So I'm going to say split by, and let's say I'm going to split by, we have two categorical, I'll do it by gender first. Okay, so I'm going to put in gender. What that will give me is the descriptive statistics for well-being, but taking into account participants' gender. So if I run that now, sorry there, what have I done wrong? Oh, I just spelled it wrong. So it's split by, just spelled the input or the argument wrong. Okay, now if we look at our descriptive statistic table again, we still have our well-being, but now it splits it by gender. So we have female 260 participants, male 160. Neither have missing data for well-being. The mean for females is 58.8, males 58.0, and so on, right? So this is making getting a bit more precise and sophisticated information. There's a lot of information here about plots that we can generate. I'm going to ignore that for now, we'll come back to it. But towards the end you'll see that we can specify whether we get the mean, median, mode, sum, standard deviation, variance. And for some of these, like the mean, we already get that. And if you look at the usage, and you look at all these arguments, you can see that mean is equal to true, which means that by default this function will display the mean unless we set it to false. But if we look at something like a standard error, which is under SE, and if I look at here, we can see standard error is here, but it's set to false, which means it won't do it by default. And let's say in this case I do want to display the standard error, so I can type in SE equal to true. If I run this again, what I get is I get the descriptive statistics, but now I get a row for females and males on the standard error. I can do confidence interval, that's CI. Again, I can do the same process. I'm just adding it in here, and I'm going to override. Currently it's set to false. I'm just going to override it and set it to true. Like at confidence intervals, I can get the interquartile range. I can set that to true. So IQR, which is here. Set that to true. And I'll do a few others. PC, that is percentiles, if I'm correct. So if we go down here, PC provides percentiles, so I can do that. And is there anything else? I might put in the range as well. And what we have now, we have our confidence intervals, we have our standard error, we have our interquartile range, we have our range, and we have our 25th, 50th, and 75th percentile split by, for well-being, split by gender. Okay, so you can see now how we can take a base function and we can change certain default arguments or inputs to kind of give us more information and kind of customize it. Okay, so now I'm thinking about how we can actually use this to use plotting, right? And there's a few things we can get from it. We can get a histogram, we can get a density plot, we can get a bar chart, we can get a box plot, a violin plot, a dot plot. So what I'm going to do here, we can get a QQ plot if we're checking normality. So what I'm going to do is think about adding in first maybe a bar chart, right? And all I can just type in bar equal true. So we get the same descriptive statistics here, but you can see now on the right in our plots pane or plots tab of the files pane, it gives us female and male scores on well-being split by gender, right? So if I copy, what I can do is if I want to copy this image, I can export, copy to clipboard, right click somewhere, copy that image, and let's just say open up a Word document, and if I click this option here as picture, there we go. There's our bar chart, and it takes 2 seconds to generate, and it's in a nice style. Okay, so that's one option. Other things we can do is I might want to put in, if we go back to our help, if I want to put in, let's say, a box plot, the argument name is box. It's currently set to false, so I'm just going to set it to true. Again, what happens here is that it creates now our box plot. And we have females and males, and it also identifies outliers for both males and females. That's useful. I can also add a histogram, and that's under hist. Let's set that to true. Don't worry about that warning message. And the order in how it displays the charts is different, so it has run it, but it's just I have to navigate through the plots, through this part. If I click back one, you can see now we have the histograms for both males and females on well-being. Okay. If I wanted to plot the density or distribution of those scores, I can just type in dense and type in true. Runs the descriptive statistics again, and I just have to go back to the histogram, and we can see now it's plotted a density distribution for both genders. Okay, so that is a lot of information that we can get out of this package or this function descriptives. A few other things we can do is, let's say I also wanted to check for certain assumptions, let's say normality like Shapiro-Wilks. And what I can do is, let me do that if I type in SW, which if you see down in the help section provides Shapiro-Wilks p-value. I just type in SW equal to true, and it gives me the Shapiro-Wilks test statistics W, and then a row and descriptive statistics also the p-value. Okay, so that's pretty useful, but we can also specify that we can get more information on different variables in our data set. So I might do well-being and depression. And if I run that again, it will do everything like done before, but it will add in the depression column in our descriptive statistics table. So we'll split it by females, gender as well, and it'll give us all descriptive statistics. And if we look at our plots, we can see it's already created a bar, our box plot for depression based on gender. It's created our distributions based on gender. our bar chart based on gender, and if I keep going back, I'll come back to the well-being plots as well. So I'll have it all there, and if I ever want to export one, I can save it. I can click export, save it as an image or PDF, or just copy it to clipboard and just paste it into Word. Okay. So one thing we might also want to do, we might want to split it by more than one categorical variable. So I might say split by gender and condition. So whether they're in the high caffeine, low caffeine, no caffeine group, and press run. And again, what happens is that we get a lot of information then, maybe too much information, right? Depends on what we want. So if we look at, like, say, the mean score, it breaks it by the female and then the 3 caffeine conditions. And it does the same for males, mean, male, 3 caffeine conditions. In terms of the figures, what now is it'll create the same figures, but it'll take into account that we're looking at depression, gender, and also the condition group, right? So it creates a legend here specifying different colors for each level of our condition: high caffeine, low caffeine, no caffeine. It does the same for the histogram and density distributions. This one for depression. Same for the bar charts, gender, depression. And same again for gender well-being. This is also one of the reasons why I changed the name of the variables, because this is more easily, like if I had just well-being here, this might not be able to be publishable already. Whereas if I change the name to something straightforward and clear, then I can publish it. So if I copy this, I'm just going to copy this to clipboard and paste it into, just one thing, if you're pasting into Word, just make sure that you paste it as an image and then you can resize it. Okay. So where are we? That's grand. So in terms of kind of last things on descriptive statistics, the one thing that's kind of missing is that we can't, with this package, use or check for homogeneity of variance or Levene's test. So to do that, we have to use a different function called Levene test. And the formula is, let's say, your dv times your iv, and you specify your data, or data frame, just RDF. So to do that now, I'm going to type in Levene test. That's well-being times, we'll do gender first, data being well-being underscore df. Oh, one thing that worked for me, but it was supposed to come up with an error. The one thing you'll need to do for this to work is just load in an extra package called car, and that runs the Levene's test. It does other things, but that's one of the things it does. Just remember to install it and then use library to load it in. So that does it for that, for well-being gender. And I'm just going to copy and paste this in and say well-being times condition and run it here. And we get our results down here again. We get Levene's test for homogeneity of variance. And what it tells us is the F value and then the PR, that's just the P value, right? And we can see for both conditions on well-being, there is homogeneity of variance. Okay, so that pretty much concludes this video in terms of descriptive statistics. One kind of final thing just to kind of note is that there are a multitude of ways of running descriptive statistics in R. This is like one package and one approach. There are a multitude of other ways, so if you're looking up online, you might find different ways of doing it. They're all perfectly fine. I just find this approach simpler and it gives me all the information that I want, and I like the fact that it creates easy plots as well. So that's why I'm teaching you this particular approach. But there are other approaches out there which you might find more useful for your data analysis. Okay, So that concludes this video. In the next video, we'll take this data frame and we'll run both a between subjects and paired subjects t-test.